Hey, we're here with Bri, and we're going to learn about machine learning with .NET. Hey, welcome to another episode of On.NET. Today we're going to be talking about ML.NET with Bri, who's one of the people working on that. So how about you introduce yourself, and then we'll get into the topic.
Sure. I'm Bri. I work on the .NET team currently, focusing all my time on ML.NET for about the past 6 months. And ML.NET was actually released at last year's build, and this year we finally went into 1.0.
Yeah.
So really exciting. Mm-hmm.
It's always fun working on that 1.0 release, because there's usually like all these foundational decisions, some of which will never get undone. Like that's the one we're going to go with for the rest of time. So I imagine there was some of that went on in the leading up to 1.0.
Definitely, yeah. A lot of stabilization in the API, and and we also added really cool new tools that are in preview that I'll talk about a little bit later.
Can you talk a tiny bit about? I know there were a bunch of different teams that were involved. How was that? Was there a bunch of give and take, or was everyone kind of moving in the same direction? Or a little bit of both? A
little bit of both, definitely. I think different teams kind of have their different opinions, and especially with all the different offerings we have at Microsoft for AI and ML, it can get a little bit difficult sometimes, but in the end, it really came together into a really great product, and everyone worked really well together. So.
Awesome. Okay, so what do you want to talk about first?
Sure. I guess I should explain a little bit about what ML.NET is.
Good idea.
And basically, it's just a free, open source, cross-platform machine learning framework for .NET developers. Our goal is really to make .NET great for machine learning in a lot of different types of scenarios. So we have kind of these...
Well, yeah, I was going to ask a question first, which is, so there are these other machine learning things. So I know there's TensorFlow. There's a bunch of stuff in the Python space. You might say some of their names. And then there's like this Onyx thing. And then there's probably other machine learning AI things that even Microsoft makes available. So before we get into the details of ML.NET, where would you say it sits? Is it competitive with all of those things, or complementary?
I wouldn't say it's competitive. What makes it unique is that it brings machine learning into the .NET ecosystem. So existing .NET developers can then use their existing C# and F# skills to integrate machine learning into their .NET applications. So they don't have to go and learn a new language in order to do this thing with machine learning, which before they did have to. And a lot of times when they had to do that and move to other languages or tech stacks, it would be kind of difficult to then integrate that back into their .NET applications.
Okay, one more question related to that. I'm hesitant that we're going to go into the weeds, but there's also this TensorFlow Sharp thing, and one can describe that as bringing machine learning into the .NET ecosystem, but I'm somehow guessing that TensorFlow Sharp and ML.NET are not exactly the same.
They're not, well, especially because ML.NET is being worked on at Microsoft. And so TensorFlow is actually for deep learning, whereas ML.NET right now supports classical machine learning scenarios. That would be things like sentiment analysis, price prediction, and deep learning gets a little bit more into image classification, object detection. And so what TensorFlow and Onyx do is they were able to extend ML.NET and use those in order to add those scenarios.
Yeah, what I specifically meant was TensorFlow Sharp. So there is this library that is a C# binding against TensorFlow, but your answer is probably still fine for that. Okay, sounds good. How about we look at your table?
Sure. So I've kind of already talked about how this is built for .NET developers. So you stay in the .NET ecosystem, but not only that, you don't really need existing knowledge of machine learning, and I'll get into that a little bit later, but we have these really cool tools that kind of abstract away the data science from it. So I'll get into that later. It also just makes it really easy to create custom machine learning models. So right now, for instance, with cognitive services or things like that, they're pre-built models that you use on your data, or you use to make predictions, right? And so what ML.NET you can do is make your own custom models with your own data. So it makes it more specific for your scenario.
Right.
Yeah. And I kind of already talked a little bit about how it's extendable with TensorFlow and Onyx and things like that for even more scenarios. And what's really cool is that ML.NET is not actually just a year old. It was actually used in the company started by Microsoft Research for the past 8 years, and it's used internally in a lot of huge products, Power BI key influencers, Outlook meeting insights, Bing suggested search, and kind of the list goes on. So it's been used here for a really long time, and what ML.NET did, or what we're doing with ML.NET, is making the API friendlier and open sourcing it so that other people can then use it.
Makes sense. So one high-level question based on what you just said, which is, you said, there's some pre-built models that you can just use as is, but you can also train, you can build new models based on your own data. Well, imagine, I've got an, umpteen terabyte, I'm just making up that number, SQL database. It's got all this data in it.
Right.
Like, how do I think of connecting all these rows and tables in SQL Server to ML.NET?
Right, so you actually can. You can load in your data from a file or from SQL Server. And what you do is you load it as an enumerable.
Okay.
So you can do it from streaming sources like that.
I see. And, okay, and that works pretty well.
Yeah, and it does.
And is it, I guess, imagine, I don't know if you have any numbers, probably something smaller than umpteen terabyte. Like, do you have any numbers that talk about how long it takes to train a model with, say, a certain size of SQL Server?
I don't think I have the numbers off the top of my head. I know we did train, I think, a terabyte of data, and it took a few days.
Okay.
Well, and that was with Model Builder, which again will be coming up.
Okay, so that gives people a sense. And now, if you're training, this is that activity, that 1 to 2 day thing for that large, a terabyte, that's pretty big. That's not something you're running in like a CI/CD flow. That's something that's more of a one-off activity that you do, and then you get this model out of it, and then you check that in somewhere, and then you kind of run with that for a while until you decide to replace it.
Yeah, exactly.
Okay.
Yeah, and I'll actually show you a little bit of code here. First, so sentiment analysis is a really commonly used example to show machine learning. So I'll show you this Blazor app here, which has real-time sentiment analysis. So if you say something like, ML.NET is awesome, you can see the slider goes up. If you say something like, that is rude, you can see the slider goes down. And so what this is doing is using an ML.NET model in this Blazor application. And I will go into the code here. And lots of tabs.
After we get through this, I want to try one.
Sure.
But let's go through this first.
Sure. And so what's really cool is the steps are kind of the same for every time you train a model. The first thing you want to do is create this ML.NET environment or ML context.
Sure.
And that it's kind of like DB context in any framework conceptually. And then what you do is you load in your data, and at this point it's just this Yelp labeled.txt, which I'll give you a little preview of that. You have your text here, and then your sentiment here. So 1 is positive, and then 0 is negative.
Right, so this is our data source. This is like the SQL database in this sense.
In this case, it's just a text file, but yeah, this is our data set right here for training. So then what you do is you load in from a text file, this where you have your data path here. You're specifying that there's no header. And if we look into this sentiment data.
This reminds me of mail merge.
Yeah. I've actually used that very recently.
Okay.
Sentiment data, you can see here that all it does is it's a schema for your data set. So you have your sentiment text, which is a string, and then your label or your sentiment that you want to predict is a Boolean. So that maps out here, and you're loading in that data. We are right here. And then data view is a way that data is represented in ML.NET. It's really flexible and efficient way for looking at tabular data that's rows and columns. So what we do is load it into that data view. Then what we do is we add data transformations. The way that it is now with the text, that actually can't be accepted by machine learning algorithms. It has to be featureized into numeric vectors, which will be accepted by the machine learning algorithm. So we've added this featureized text data transformation here, and we've added that to what we call our pipeline. And then what we do is we choose our algorithm. In this case, you can see that we have quite a bit to choose from for binary classification, which is our task for sentiment analysis. Right now, we'll just choose SDCA logistic regression. And
yeah, I'm guessing get hash code isn't one of them.
Yeah. And then step 4, you just train your model. And so as of now, before you call this fit method, this is just it has a lazy approach where you're just kind of adding things to the pipeline. Once you call this fit method on your data, it actually starts the model training.
Right, and one interesting thing is, often we talk about async with a lot of the .NET product, but these look like these APIs are all entirely synchronous, and I think they're intended to be run in this like standalone batch process kind of model. So yeah, that's why they're synchronous.
Yep.
Yeah.
And then this is kind of an optional step, but usually you probably want to do it. You want to evaluate your model. And so what I've done is taken a separate data set, which is, it looks the same, but it's just reviews from Amazon instead of Yelp, and use that to get evaluation metrics. So you load in from the text file, you make predictions on that test data, and then you get a variety of metrics here. And in this case, it prints out the accuracy. So then what you could do is save the model at the end and then use that in any other of your applications. So that could be web app, what else? You can do console apps, desktop apps, WinForms, microservices and containers.
Yeah, mobile apps.
Yeah.
Right, and so another takeaway is, I take it the training app and the app in which you're consuming the model are always going to be different.
Not always.
Okay.
They can be the same, especially like, for instance, you can make a single prediction in the console app that you are training the model, but in most cases they will be separate.
Okay, and that would be kind of not the most common case.
Right, exactly.
Yeah. So most of the time they're separate apps.
Yeah, exactly.
And this is either going to be a console app or just like a very minimal UI app that has probably relatively few buttons.
Right, yep, exactly. And so what we've seen so far, and with all of our samples that we have on GitHub, all the training is done in console apps.
Yeah, actually, back to my question about CI/CD, I guess I can imagine, imagine you and I set up this company together and we're like super pro at this, and we want to have the best trained sentiment analysis. I could imagine that, every night we have this batch job, which, there's more data that came in through that text box, and we just rerun all of our models.
Yeah, you definitely can do that.
And then we just see if they have better results. And if it, has a significantly better result, then it's like, oh, well, maybe we should just deploy this new model.
Right, yeah.
Meaning it doesn't have to be the case that you only run this like once a quarter.
Right, you don't have to do it that way. Some people will do that, but if you're getting better data, it's definitely better to add that into your data set for training.
Right. I mean, even if it takes 2 days to run, like you said, I guess maybe we could just do it once a week. And
yeah, and then you get a better model.
Yeah, okay.
Yeah, definitely. And so I'll actually show you what this looks like when I run it. You can see right now this ML models folder is empty. So we'll go ahead and start running that. Maybe. There we go. So you can see we added a few console lines there. We actually printed out the accuracy, which is about 75%, and then we saved the model.
Okay.
And
from kind of some exposure to this in the past, 75% is probably good for the amount of time we took on that, but 75% in the general case is bad. Or is that the wrong way to think about it?
It's actually not. It definitely depends on your scenario. It helps to pair the accuracy with also trying out predictions. In this case, if you try out a lot of predictions, I know you wanted to try another sentiment one, and it's a pretty good data set, so it'll do pretty well. Once you start getting into the negations, like it is not good, that's where it has a little bit of issues.
I see.
Yeah, and that's common for sentiment analysis. But
okay.
But you can see the model here is just a serialized zip file. And if we actually come up back to this program.cs, where we actually consume the model or use the model and make a prediction, where we have ML.NET is awesome and that is very rude, we're actually going to, all we have to do is, so I've already made a reference to the generated libraries here, the class libraries here in our predict sentiment project. And I'm actually going to drag this up here so that it can use the model.
Right, that we just built.
That we just trained. And then we'll go ahead and start that. And then you can see ML.NET is awesome. It predicted it as a positive sentiment.
Oh, I see.
And that is very rude, which is our text, is a negative sentiment.
Right. So I take it you could build like XUnit unit tests, for example, that did something very similar.
Definitely. You definitely can.
Is that what people do to validate the model, or I guess since the training Yeah, I guess how do people test?
So, well, there are those evaluation metrics that I mentioned. If we go back to, I believe it was here, where we trained our model, and we come to metrics.accuracy, you can see that we have quite a bit of different metrics, which of course, some of them might not make sense, but we do have in our docs kind of explanations of what these things mean, and they are common data science
Right, they're
metrics.
all useful for different
So that's
reasons.
one thing, but that is also, the way that you explain is also a way that people can do it. I haven't quite asked around yet to see how people are really using it.
Okay.
That's kind of our next step, is to see like the different ways that people are using it, the different scenarios, how they're testing it, and all the different cases.
Okay,
So.
that makes sense. So we're going to try my...
Yes, let's try.
So it is, you are being obtuse. OB. Okay, I thought that might break it, because I think obtuse is not...
It's probably not in the data set that we used,
yeah,
right?
Well, and obtuse is kind of an obtuse word.
Yeah.
So that was me being clever.
Yeah, any other ones you
no,
want to try?
No, that was the only one I wanted to try.
And so that's just one of the many scenarios, and I'll actually show you here. Some of the other scenarios we have, product recommendation, price prediction, segmentation, and we have all these samples on our GitHub. If you clone that, you can just try them out of the box.
I have another one.
Sure, let's try it.
He is acutely aware of his intelligence. Huh? Wow!
I mean...
apparently I'm good at breaking this thing.
Yeah. We may have to add that to the data set now
Yeah,
and train it on the
totally,
data set.
Totally.
So another really cool example that I like showing is object detection. This one's one of my favorite ones. So you can see here.
Right, so this is kind of like the bounded box scenario.
Right.
I assume if you were doing, some of these programs where you have like a photo collection, we'll say like, oh, these are all the pictures of Bri in my photo collection. They assume as the basis of that, they use something like this to figure out where the person is.
Right. Yeah, I'm pretty sure. And what this is using is an Onyx model, actually. I believe it's our Onyx YOLO 3 is what it's called. And this is actually in our this is in our GitHub repo, so you can download this and try it yourself. I changed out the pictures, but you can try out your own pictures. You can see here that it's located this TV monitor, this bottle, and this chair from my focus room. And we've even got my living room here with a sofa and a potted plant.
Right, so the way this program is running is the idea that you click that button and I guess those are already resident on the server. This is the pre-object detected version of them on the right.
Yep.
And then you're getting those images served back to you with the object detection put in them.
Right,
Yeah.
exactly. So it uses that trained model.
Okay.
And I think the objects that it can identify are like sheep and sofas and dogs and cats. So it's trained on specific things to recognize, specific objects to recognize. So for instance, it might not recognize like grass or a table or things like that. But I'll show you another one just to show that you can choose any image here. So here you can see it actually identified a boat from just the images that I had there.
Okay.
Yeah.
And it's the sort of thing where, at least with my understanding of this stuff, if you trained it exclusively on white boats, and then all of a sudden it saw an image with like a blue boat or a red boat, then it might get confused.
It might, yeah.
Yeah.
So definitely it's better to have a variety. And also just giving it images of not boats, if that makes sense.
Yeah.
So having just a variety of both, is the best for training the model. Those are the demos I had. It's pretty crazy the different scenarios that our customers have been using this for.
Right, so you have customers?
We do, it's great.
You just released your 1.0 just now, so is it the case that you just had this growing set of customers along the way? Or do they come mostly at the end, or a little bit of both?
So we actually had some before we even hit 1.0, which was really cool. I'll actually get into a few of them because it's some of my favorite stories here. So my top favorite one is Evolution Software. I think they started with version 0.4 or something like that, and they've been upgrading ever since. But essentially what they do is they do commercial hazelnut drying. And so this is a commercial
Doesn't
hazelnut dryer.
sound like a software company.
Yeah, no, it doesn't. This right here holds 50,000 pounds of hazelnuts. And the business problem they're having is hazelnuts have to be at a certain moisture level in order to be profitable. So if you over dry them, they shrink, you lose money. If you under dry them, they can get moldy and you lose money. And so the process, the way that it works now is people have to climb into here as it's drying and do a sampling. They take a bucket and they take out hazelnuts and they manually test to see the moisture level. They have to do this every so often, and the conditions are less than ideal. It's 120 degrees Fahrenheit, 100 mile per hour winds. It's just not great. And so what the people at Evolution Software wanted to do was kind of eliminate this manual process. So they used sensors to gauge temperature and pressure, and then they used the sampling data that they had before as training data.
Oh, wow.
And so what they can do is predict the moisture level of the hazelnuts based on all of that. And so they actually created this application here. And they use SignalR for real-time updates. They use they're on ASP.NET Core, using a lot of .NET products.
So they're like totally all in.
Yeah, they are. And so they actually created this for the operators that says, hey, this batch is ready, you should go get it, or this is already too much, or this is how much you have left.
It's in the danger zone.
Right, exactly, in the danger zone. And I now know that it has to be between 8.5% and 11% is the ideal moisture level for hazelnuts.
Yeah, it sounds a little bit like a humidor that people use for cigars that you sometimes see in stores.
Yeah, it's similar, so maybe someone will
Yeah,
use ML.NET for that one day.
Although I'm actually not a cigar smoker.
Yeah. Then another case that we have, Brenmore, is really cool. So they do surveys for patients after they come to do doctor's visits, and they collect that data and try to improve the patient experience. And so what they had was all these surveys and all the survey data, and they had these free-form comments, and they found that it took a really long time to parse through them manually and then direct it to the correct personnel. And so what they're using ML.NET for is classification of those comments. So both to say if it's toxic or non-toxic, so is this a good or bad feedback, but also to put it into categories such as experience, facility, provider, staff, and things like that, and it'll automatically route to the correct personnel.
It sounds a little bit like GitHub issue routing.
Right, exactly. Well, that's actually the one that we use we have that sample in our repo, is using multi-class classification for GitHub issues. And one of their quotes here actually was, they mentioned AutoML, which I haven't talked about yet, and I want to get into that a little bit, but they used one of our new tools called Model Builder that uses AutoML, or automated machine learning. And what that is it essentially generates a model for you based on your data and your task. And I'll show you with the sentiment analysis one right here. So the way that it works is you download the Visual Studio extension, it's called Model Builder.
Okay.
And you open Visual Studio. All I've created is a .NET Core console application. There's nothing else, just hello world. And what you do is you right click and you say add machine learning. And you have a few different scenarios. Right now it supports classification and regression scenarios. And so we'll go ahead and do sentiment analysis because that's what we've been doing. You can do it from file or SQL Server. I've got a file ready, so we'll go ahead and do that. Oh, wrong file. Here we go. And so what you can see here is a little data preview where it has the sentiment and then the sentiment text, just like we saw before. It's just a different data set. And what we want to predict is the sentiment. So we want to, once we get this model, we want to be able to feed it sentiment text or comment text and then get the sentiment back. So that's what we're going to predict here. We're going to move on to the train step. And we're going to specify a time to train. We're going to leave it at 10, which is the default. If you have more data or you want to use it in production, you usually want it to train for longer. And what it's doing right now is it's using AutoML to iterate through different algorithms, data transformations, and algorithm options to give you the best model or the highest performing model. And so you can see here, it's all the models that it's going through, the one that it's found is the best so far, and actually the accuracy of that model. And so if you go to the evaluate step, it shows you a few evaluation metrics. Accuracy is a pretty good one to gauge. And you can see that it shows this average perceptron binary, which is actually different than the one that I had before. But I don't know much about algorithms, so this takes care of that for me.
It all sounds good.
Yeah. And what's also really cool is once you go to the code step, it'll actually generate the consumption and training code for you. So you add those projects, and you can see here, it adds over these to the right. You open this model builder, and you can see the steps are very similar to what I had manually written before, but it just generates. And I don't know why all these red are happening here. But then this one, you can actually run your model with program.cs and lots of red, perfect. It generates those class libraries for the sentiment and sentiment text.
Nice.
And the predicted label here. And so then what you can do is go back in here and use your model. And if you go back to Model Builder, it actually has that code that you can just copy paste over and you're able to use your model that was generated.
So are you thinking about, so this is obviously a Visual Studio plugin that gives you this experience.
Yep.
Are you thinking about any outside of Visual Studio experiences for the model building?
Yeah, so we actually have the ML .NET CLI, which does the same thing.
Okay.
Actually, ML .NET CLI is kind of behind the scenes here in AutoML.
Okay, perfect.
This is just a UI put right on top of that, and I'll actually go back.
Because obviously, if we're back to our example, if we were wanting to like run this once a week on an ongoing basis, we probably wouldn't want to do it manually in Visual Studio.
Right. Yeah, and so we have that option, and it's really good, especially for getting started. But we also have it right on the command line. So.
Awesome.
Both ways, yeah. So it's in that way it's cross-platform as well. So Mac, Linux, Windows, you can use automated machine learning. Yeah.
Awesome. Okay. Do you have any kind of closing thoughts on things you'd like to share? You know, where should you go if you want to get started? Yeah,
to get started, it's very, very easy. I'll type it in here for you, but .NET/ML, and that'll redirect you to the page that I just showed you. Maybe.
I think maybe those red squigglies would maybe due to some internet connection problem.
I'm sure. I'll just bring it back here. But there's a big Get Started button. This will lead you through how to install Model Builder and get started with it, and also the CLI, so whichever way you want to get started there. And then another great way is to just go to our samples on GitHub and just try those out. A lot of people, the way they started was downloading one of the samples and then just adapting to their own scenarios. So any of those ways, it's super easy to get started. And if you have any feedback, please on the GitHub, let us know.
Yeah, and file an issue or whatever.
Yeah.
Okay, awesome. Well, thanks for being on the show and teaching us about ML.NET.
Sure, thanks for having me.
Yeah, okay, well, this has been another episode of On.NET, and I hope you learned something about machine learning. Thanks.